Assalamu alaikum, students. Students, in this lecture, we are going to do the application of the shapes of molecules. Like in the previous lectures, we did all these. That how the valence electron pair repulsion theory explains the shape of the molecule. But now I am going to apply and to explain it in more detail, right? And I hope at the end of this lecture, you would be able to understand how to find the shape of any molecule. And now I'm going to explain this on the separate page. I will use these notes. These notes are available on my website, Chemistry by Zeenat, right? So coming to this topic, look. When you are going to apply a few things, shapes of molecules. In the previous lecture, what we did, that if it is AB2 is the central, it's 180. No lone pair, linear. This is what? Linear. If it is AB3, and the other case is what? AB2E. AB3 is the central atom. There are 3 bond pairs, no lone pairs. Is the central atom. There are 2 bond pairs. There is 1 lone pair. Now, if all 3 are bond pairs, there is a maximum separation of 120. Trigonal, planar. The lone pair occupy more space. So it becomes 117, bent. And then the next case, AB4, AB3E, and then AB2E2. All 4 shared. Three shared, 1 lone. 2 shared, and 2 lone. So 109.5 tetrahedral, 107 pyramidal, 104.5 bent. Tetrahedral, trigonal pyramidal, and bent. And now, last one is AB5, one is AB6. They are quite obvious situations. AB5, trigonal bipyramidal. 3 are planar, one is up 90, one is down 90. So 120 and 90. And it is what? Trigonal bipyramidal. Trigonal, this is trigonal. One pyramid up, one pyramid down. Trigonal bipyramidal. If it is AB6, one up, one down. It's octahedral, 90. All 90 degree and octahedral. Right? So now coming to some other things. First point. Every single double, triple, and lone pair, each is one region. One region, one region, one region. So when there would be a double bond, you will count the double bond as one shared pair. Right? A double, a triple, a single. Each is one shared, one shared, one shared. This is one lone. And next, Elements of period 2 can accommodate 8 electrons. The elements of period 2, beryllium till neon, their capacity is 8. They follow octet rule. But period 3 and 4, they don't follow the octet rule. They have expanded octet. Their last shell have capacity of more than 8. So now how we are going to apply all this? Look. If I make a periodic table in front of you, it's transition. This is group 0. Group 2, 1, 2. This is 3. This is 4. This is 5. Yeah. 6 and 7. Good. Now, this is lithium, sodium, potassium, more than enough. Beryllium, we are not even using these because we are doing covalent bonding. Beryllium, magnesium, calcium. Now, this is boron, aluminum. This is carbon, silicon, germanium, nitrogen, phosphorus, As, oxygen, sulfur, SATE. This is fluorine, chlorine, bromine, iodine. And you know, hydrogen also make one bond. So I'm putting hydrogen. Look what we are going to do. You know, beryllium and aluminium. This I'm going to explain later on, that they are chloride, bromide, iodide. They're chloride, bromide, iodide, bromide, iodide are all covalent. They're all covalent. But their oxides and fluoride are ionic. Why? We are going to discuss this later on, right? In electronegativity topic. Now, but why I am writing these two? Look, this is beryllium. It's making a covalent with group 7, right? There are only 2 electrons in the last shell. There is one group 7. It is chlorine or fluorine, anything, right? This is chlorine. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. If you see, there are 8 electron, complete. But if you look at beryllium, in the last shell of the beryllium, there are 2 shared pairs. There is no lone pair. They're equally repelling each other. And they're at the maximum separation of how much angle? 180. They are repelling each other. They're at the maximum separation of 180. This is a shared pair. Sorry. A shared. There is no lone pair here. No. So they're equally repelling. Although its last shell is not complete, I agree. You know what it will do to complete its last shell? Dative bonding. That we will do after this, right? After this topic. So, maximum separation at 180 linear. Another example. See, there is this HCl, carbon, element of group 4. This is nitrogen. Group 5, this is group 4. See? 4 bonds. Group 5, how many bonds? 3 bonds to complete. And hydrogen need how much electron? Only 1. So how they are going to make bond? Hmm? It needs three bonds, 1 bond, and there are what? 4 bonds. So what it will do? Is this possible that they make 3 bond and 1 bond with this? Yes, of course. So what carbon will do? This is hydrogen. See, this is hydrogen. This central carbon will make 3 bonds with the nitrogen and 1 bond with the hydrogen, so 4. And the nitrogen will make 1, 2, 3, and 4, 5. See, the hydrogen making 1 covalent bond with carbon and making triple bond with nitrogen. Now, when we talk about the angle, the central atom is the vertex. Like every angle has a vertex, 2 arms. The central is this one. This central atom has 1 shared, 2 shared, 3 shared. So it's 1 shared region. Triple bond is counted as 1 region. 2 region. These 2 regions are at the maximum separation of 180. Right? Like you will count this 1 region and another region, there is no lone pair, nothing. The 2 shared pair are equally repelling. They are at the maximum separation at 180. If you see carbon dioxide, this is carbon. This is carbon. Last shell having 4 electrons. And this is any group 6. What group 6 will do? I'm telling you one trick. It's very interesting. Look, this is group 6. 1, 2, 3, 4, 5, 6. This is one group 6 making 2 bonds. This is another group 6 making 2 bonds. This is oxygen. How they can make bonds? Is this possible? The 2 with this share and 2 with this one? Of course. So then what will happen? This is your carbon. This is your oxygen. No, group 6, sorry. Group 6. 1, 2, 3, 4, 5, 6. Agree? The other group 6. 1, 2, 3, 4, 5, 6. What about carbon? 1, 2, 3, 4. If you see, the carbon is making a double bond with one group 6 and a double bond with another group 6. And there is the maximum separation of how much? 180. Why? Because this shared pair and this shared pair, they are equally repelling each other, Maximum separation at 180. Linear. You know, you can put oxygen here. It becomes what? Carbon dioxide. If you put sulfur here, it becomes what? Carbon disulfide. If you put one oxygen and one sulfur, it becomes what? OCS. Yes, they exist. There are questions in your past papers that draw the dot and cross of what? Carbon dioxide, carbon disulfide, and OCS. Right? So if you see the HCN, the triple and the single are at 180, the BeCl2, they are at 180, and these are three more examples. They're based on this. They're all linear, 180. And they're all what? A, they're all what? I'm using A, B2, 180. Agree? Look, this is what? A, B2, no lone pair. This is what? A, B2, 180. This is also what? A, B2, 180. Now coming to another example. If you have group 3, group 3 and group 7. One, two, three, four, five, 6, 7. This is group 3. It will make how many bonds? 3, although its last shell will not be complete. It's just like the beryllium situation. You know, there are some compounds in which they're like especially beryllium chloride, not complete, aluminium chloride, not complete. But what they do to complete their last shell? Dative bonding. This we will do in the next topic, right? Now, this is group 3, making 3 bonds with a group 7, of course. Like, if I take this group 7, this is group 7. 1, 2, 3, 4, 5, 6, 7. Another group 7. 1, 2, 3, 4, 5, 6, 7. Another group 7. See? 1, 2, 3, 4, 5, 6, 7. Right? If you look at this one, this is what? Your A, this is B, this is B, this is B. There is no lone pair. So, if this is AB3, if I bring the periodic table down, wait. See? This is making a bit small. I left one of the, I'm removing this. See, this is group 3 and this is your group 7. Now, their last shell is complete. It's complete. But what about the central? This one. This last shell are not complete. It's a group 3 element. Of course, I told you that the boron and aluminium, anyone here, boron will, beryllium and aluminium, they have exactly identical properties. Like when you find them somewhere, there are too much similarities in their properties. But here the boron is also behaving like them. The last shell is not complete. Like if it is boron with 3 fluorine, boron with 3 chlorine, BCl3, aluminium chloride. Huh? Suppose it is aluminium bromide. So what is common in all these? The last shell is not complete, but there are how many shared pair? 1, 2, 3. So it's what? It's what? A, B, B, and B, A, B3. Maximum separation at 120. Trigonal planar. Right? This is AB3. This is AB3. Now listen. Another example of the same AB3. One is SO2, one is SO3. Now in SO3, see, sulfur is a group 6, period 3. Oxygen is of group 6, period 2. Its capacity is just 8 electron in the last shell. It can accommodate more than 8. Yes. So how we are going to do? This is sulfur group 6. You know, 1, 2, 3, 4, 5, 6. Right? This is sulfur and oxygen. There is this one oxygen. The oxygen need how many electron? The oxygen need how many electron too? Because it is of group 6. It is of group 6. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is of group 6, needs 2 electron. It will share 2 electrons with the sulfur. Agree. Another oxygen, 1, 2, 3, 4, 5, 6. Another oxygen, 1, 2, 3, 4, 5, 6. So, sulfur is making one double bond, another double bond, another double bond. The oxygen has 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Its octet is complete. It's the element of period 2. There is no issue, but with the sulfur, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. There are 12. Sorry, I'm sorry. There are 12 electrons. So the last shell has more than 8. It has expanded octet. Expanded octet. It's the element of period 3. Its capacity is more than 8. One thing I want to share with you people. See, the first topic is what? In the topical, you will find this topical on my website, right? The first topic is the first 23 questions are of shapes of molecules and angle. Like first one is beryllium chloride, linear. Then CS2 again linear. Then OCS again linear. Look, I want to share this with you people. If you see what they're writing, they are saying that both contain only what? Double bond. It's clear cut written. Most of the time, because they know that student can go for dative bonds, for something else. So instead of making incorrect, if you read your question clearly, you will find that you people are guided most of the time. So if it is SO3, if there are all bonds double bond, this clear cut indicate that with one oxygen double and another with another oxygen double and with another oxygen double. And here also double. Right. What they're asking, shape and angle, shape and angle. It's a 4-mark question, and maybe there are some more. Now this is for ammonia, something. Yeah, again it's what? SO3. Each oxygen atom form double bond. See? Like most of the time, the students are guided with the situation where they find that it would be difficult by the student for the student to handle. Right? So coming to the explanation. So what I did, there is double, there is double, there is double. Okay. Now, when I make this double bond as double bond O, double bond O, and double bond O, hmm? is it is this the situation of A, B, 3? Of course. It is how much? 120 trigonal planar. And if I do the same for this one, if I do exactly the same for SO2, look what I'm going to delete this oxygen only. So it becomes SO2. Yes. What is the difference? This is A, this is B, this is B with a lone pair. Don't you think that it is AB2E? Yes. So it is what? SO. The lone pair occupy more space. They get close to minimize repulsion. And it becomes what? Band 170. Right? It becomes what? 170. Now come to another to another situation, not only example situation. Now you know what I'm going to do? I'm using the periodic table again. Look, you know, when you take group 3, when you take group 3, you can join group 3 with how many group 7? Definitely. Oh, my bad. What I'm doing. This is group 3 making 3 bonds. There would be 3 group 7. No lone pair. No lone pair. 120. Instead of group 7, there is possibility of hydrogen too. Agree? Trigonal planar. Like BF3, BCl3, PBr3, BH3, ALF. Now, if you take any group 4 with how many group 7? With how many group 7? 4. And in place of group 7, what is the other possibility? Hydrogen. So it is what? Tetrahedral? Huh? It is what? Tetrahedral. Like it's like this. Sorry. I thought it's like this is group 4 with group 7. So group 4 with group 7. So can you tell me the formula? This is carbon with 4Cl, CCl4 tetrahedral. Huh? CF4, CCl4, CH4. You can even go for what? CH4, CCl4, CH4, SiCl4. See? And this is which case? This is AB4. This one was AB3. This was AB4. This is group 3. This is group 4. Now coming to group 5. Group 5. 1 lone, 3 share. Am I right? Yes. Group 7, group 7, group 7. Perfect. Group 5 will make 3 bonds. The group 5, 1, 2, 3, 4, 5. 1 bond, 2 bond, 3 bond. So they can make 3 bonds. It could be group 7 or hydrogen. Group 7 or hydrogen. Group 7 or hydrogen. Right? Now, listen. If we take example, it is what? NCl3, yes, with a lone pair, and H3 with a lone pair, of course. PCl3, perfect. Lone pair, PH3, they are all trigonal pyramidal. AB3E. Look, AB3, no lone pair. This with 4, no lone pair. Now, when group 5 is making 3 bonds, it will be having 1 lone pair. When group 6 is going to make group 6, 1, 2, 3, 4, 5, 6, making 2 bonds. So there will be 2 lone pair. So if this is group 6 making 2 bonds with group 7 or hydrogen, there will be 2 lone pairs. So it's what? AB2, E2. What are the examples? The examples are OCl2. Yes. 104.5 bent. Huh? H2O. Other example, the H2S. Yes. H2S. Cl with sulfur, group 6. See? Look, starting with this. AB2, then what? AB3, then what? AB3 again, AB3 and AB2E. And then I started with this group 3 with group 7. AB3, group 4 with group 7. AB4, group 5 with group 7. Group 5 making 3 bonds, 1 lone pair. Group 6 making 2 bonds, 2 lone pair. Right? So they are what? Their angles are what? 107 pyramidal. It's what? Trigonal pyramidal tetrahedral. And these are called what? Band. Now, the last 2 things, which are very, very easy, are what? Are SF6, like the AB5 situation and the AB6. And they're, I think, quite obvious. Like if it's PCl5, blindly go for trigonal bipyramidal. Phosphorus is the element of group 5. Phosphorus is in group 5. It can make 5 bonds because it can accommodate how many? More than 8. It can accommodate more than 8 electrons. This is chlorine, 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 chlorine. 1, 2, 3, 4, 5, 6, 7. So many electrons for chlorine. When I draw this SF6 and PCl5, I don't like this. Sorry. Like, look. This is what? 1 pair, 2 pair, 3 pair, 4 pair, 5 pair. So is this A, B, 5 equally repelling each other? And how they arrange themselves? It's like this. P with 3 Cl this way and 1 Cl up and 1 Cl down. Their angles are 120, 90, and the shape is called what? Trigonal bipyramidal. Now AB6, the easiest case, SF6. Sulfur is exactly element of group 6 and of period 3, and the capacity is more than how much? 7. So what you're supposed to do, you have to draw all the electron, right? Look, if I share with you the notes. See, I have explained all these in too much detail. Look, all the examples, like how the group 3 elements and how group 4 elements, and then even if you see, if you see the group 4 element, 4 single, then it's AB4. If the group 4 element is making 1 double and 2 single, like 1 double is 1 region, 2 region, 3 region, it's AB3. Now, if like this is the detailed explanation. Look, group 3 making 3 bonds. These are the example. Group 4, if making 4 single, if making a double and 2 single, if making a triple and 1 single. Look, group 4 will make 4 bonds in a total. All single, 2 single, 1 double, and 1 triple, 1 single. Then it would be linear. Group 5, making 3 single, 1 lone, because group 5 has how many electrons? 1, 2, 3, 4, 5. If 3 single, 1 lone, and what is the other possibility? 1 lone and 2 one is double and 1 is single. The two are double, like this way. There are possibilities, like nitrogen making a double with oxygen and air with something else, with a carbon and a giant structures. This is possibility. So all 3 single and 2 shared and 1 lone. So this is what? A, B, 2E, right? Group 6, making 2 single. Group 6, keep in mind, 1, 2, 3, 4, 5, 6. It can make 2 bonds. Now there is possibility, 2 single or 1 double. If it is 1 double, it's terminal, not making a bond. Group 7 can make 1 bond, so it's always at the terminal, not the central atom. And then I'm doing the random practice. See, all the things are given. And then there is explanation for some questions from the past papers, right? If I do one such question with you people, yeah, yes. Look, these are MCQs available on my website. If they ask you such a question, what you're supposed to do, just go to the group number. This is group 4. So 1, 2, 3, 4. It's what? AB4. It's what? Clear cut. ABB4. So it's how much? AB4 is what? Tetrahedron. 109.5. This is group 4. See, this is group 4. Group 4. 1, 2, 3, 4. Is there any lone pair? No. So it's one shared, another shared, another shared. It's what? AB3. No lone pair. Look, I want to explain this to you. I told this already. If group 4 make 4 single, 109. If group 4 make a double and 2 single, 120. If group 4 make a triple, 1 single, 180. So what you can see, group 4 making 4 single, this is what? 109.5. Group 4 making a double and 2 single, it's 120. Oxygen group 6. Group 6. 1, 2, 3, 4, 5, 6. 2 lone, 2 shared. AB2, E2. AB2, E2. In this, the angle is how much? 104.5. Do you get this? How you will do this last one? Once more. Look, this is group 6. 1, 2, 3, 4, 5, 6. So A, B2, and this is E and EE2. So 104.5. 104.5. Increasing bond angle. So which one is the largest? Y is the largest, and then Z. No. And then X, and then Z. So the answer is A. If you look at this one, how you will do this? Carbon is of group 4. 1, 2, 3, 4. It's what? AB 3. No lone pair. 3 shared region. 120. Carbon is of group 4. Group 4. Right? 1, 2, 3, 4. All single. AB 4. 109.5. Now this is group 5. Group 5. Now 1, 2, 3, 1, 2, 3, 5 minutes. 1, 2, 3, 4, 5. So A, B, 3E. There is a lone pair. So if it is AB3E, you know this. Like if it is AB4, it is 109.5, AB3E 107, AB2E2 104.5. So it's what? 107. 107. Like you can apply this on anyone's. Like look at this one. Group 5. Group 5. 1, 2, 3, 4, 5. So what you will say? This is A, B2, E. So if it is A, B2, E, a lone pair, it's how much? It's 1, 1. It's 1, 1 what? 7. It's 1, 1, 7. Right? This is what? A, B, 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 but this is group 5, a lone pair. So it is AB3E. If it is AB3E, the angle is how much? This is 107. 7. This one is 117 if they ask you, right? Now, now, now you can do the practice of all these. For all the notes, you can see my website, right? And in the next lecture, we are supposed to do this topic. See, the dative bonding. In the dative bonding, we will do further practice of the same angles so that you can memorize them, right? See you in the next lecture. Okay, bye. Allah Hafiz.